Yeah, hi. So in this video we will see the coding problem, that is, so in how many number of the ways we can make this target amount using these denominations like $1 and $5 coins. So there is no constraint in the number of the coins we have. We have unlimited number of the $1 coins as well. We have unlimited number of the $5 coins. So the question is, so how many number of the ways we can make this $6 target amount? So the answer is this. So we can make this in two ways, that is, using directly 6 coins of $1 we can make $6, or we can make $5 coin one and plus $1 coin one, which will make $6. So so how to approach this in a coding format? That is, as usual. So we will start with conceptual overview, like time and space complexities, um, and further code implementation. uh, so say for example, as usual, as this is a dynamic programming problem, we have to start with a small chunk of this, a bigger problem. So one, two, three, 1, 2, 3, 4, 5, 6. Okay. So for example, if we have been asked, so in how many ways we can make $0? In how many ways we can make $0 using no coins? In how many ways we can make the $0? So there are no coins. Say for example, forget this $1, $5 coins. There are no coins at all, and we want to make $0. In how many ways we can make? In one way, that is no coins, we can make $0. Say for example, if you want to make target amount of $1, target amount $1, there are no coins. So there are no coins, we can't make $1. So there are no ways to make it. Similarly, for remaining, these are all the target amounts to make. So we can't make $2 without having any coins. So this would be $0.04. If there are no coins are there, we can't make $6. So yeah, so we will increase a little bit by taking this. So we will use the $1 now, $1 denomination. So is it sense to say for example, using $1 coin we can't make $0. Mm, the coin itself is $1, so we can't make less than that. So this is not possible. So we have $1 coin, we can definitely make $1 target amount. In how many ways? One way. 1 into $1 is equal to 1. So I'm updating this as 1. Similarly, say, can we make using $1 denomination? Can we make $2? Yes, definitely. 2 into $1 is equal to 2. So we can make 3. Similarly, $3 we can make in one way. 3 into $1 is equal to $3 target amount. Similarly, $4, $1. Say, when I coming to $5 also, 5 into $1 is equal to $5. Similarly, 6. So we completed with $1. So we will go with $5. So as we talked before, we can't make any target amount less than the denomination coin. Say for example, here this is the $5 coin. We can make, if you want to use this coin and make the target amount, you can make the target amount greater than or equal to $5. So the minimum amount that we can make using $5 coin is $5 or more. So we need not to bother about the target amounts less than that, but we can look into this. So um, using this $5 coin, say we can use $1, one coin of $5 coin and will make $5. This is one more way. So what is this one? Previously it was 5 coins of $1, which would give 5. So I am updating a new way using this $5 coin. Say using this $5 coin, the target amount, can we make $6? I am thinking so. $6, like we can use $1. Sorry, one coin of $5, which we got newly, and that would give $5. Plus, we can use $1 one coin, which would give $1. So $6 we can make. This is already there, and we are using introducing new way. So this will be 2. So that is the answer. Like so how to derive any formula for this? So we manually calculate it to see whether we can derive any formula out of this. So can we make any formula out of this? Like, say this is an area of number of the ways we can make this target amount. Say we want to get the amount of I, where I can be of this. Uh, Say we have like this number of the ways of, this is the amount, this is the amount, and we have used $5 coin, that is denomination. Base of $1, base of 1, base of 1 is, this is 1 plus or minus 1. So finally base of, if you want to get this index, so base of 6 plus 1. Base of 6 in the previous iteration was 1. So 1 plus 1 is equal to 2. This is how we can get the any element. So we can test this for others too, other elements. Say we want to get for 5. Base of 5 plus or is equal to base of 5 minus 5. 5 minus 5 is 0. 5 minus 5 is 0. Base of 0 is 1. Plus this is equal to 2. So base of 5 is already 1 in the previous iteration. I mean before using this $5 coin. So it would add 1 to this. So this is the formula, uh, like getting this. So what are the time and space complexities of this? So if you see time complexity, for every denomination, we are iterating through the whole array, like the length of the target amount. So for one, it would be, if the denominations are d, we can think, and so d into n, where n is the target amount. That is the length of the number of the ways. So this would be the time complexity. It's I am specifically mentioning that its time complexity is not n square, because this this length of the denominations need not to be equal to the this length. So it would be just n into d. And regarding the space complexity, it is bigger of n, because where n is the length of the length or whatever the target amount. Yeah, so this is the time and space complexities. So we will try to implement this using this. Say we have number of the ways of making, change. It takes it takes two parameters, that is the target amount, and the denominations. Denoms, I call these denoms. So what we thought? So we are iterating through each denomination every time and um, putting this. So initially, as I created the array, I created using all the zeros, but just the initial base case was uh, the first element was updated as one, because using no coins we can make $0 in one way. So I am setting this in the code. Say for example, I am creating this vase. Vase is equal to 0 for I in range, like it need to set from 0. We need not to set to 0 range, the target amount plus 1, because this range will create up to target. So for example, I'm, what I'm saying is, if the range is, say for example, 3, the array will be created from 0, 1, 2, not including the 3. So if you want to create up to 0, 1, 2, 3, 4, 5, 6, we need to give the target as plus 1. So yeah, this will initiate the zeros, but I want to update the the first element in this base list as 1, and afterwards we need to iterate for I in range. We need to iterate from 1 to the same target plus 1. And what we need to do, so we need to, like, base we need to update base of plus is equal to base of the target amount. So did I write correctly? Oh, sorry, this is denom. We need to iterate for denom in denoms. Say we will take $1 denom, and we'll iterate. So for I in range from 1 to target plus 1. So we will update the base array. Base of I is equal to base of base of I plus base of I plus base of target minus denom. So this would create the base array, and finally, what is required? We need to just return the last base of base of the target, right? So this we need to return the target. Say, yeah, this is the last element in the base array. So this is iterating in n into d times, n into d. So this time complexity is because of n into d. Space complexity is big O of n because it is creating this J's. Mm, so for this, that's it. We successfully solved the problem.